SNMP is the Simple Network Management Protocol. It is a UDP-based protocol, and it is primarily used to read out remote servers and check their configuration and runtime status, but it can also be configured to allow remote management, remote configuration of a server. SNMP went through a different of variations during its life cycle, starting out with version 1, which is very insecure, version 2C, which is the most commonly deployed version, which has some level of security built into it, but not a whole lot. And then SNMP version 3, which is the most secure version, but which is not widely deployed. SNMP comes out of the box on a large number of different operating systems, primarily on more embedded control systems than on modern operating systems like a Linux or an Ubuntu, but many system administrators will turn it on to facilitate remote management and remote monitoring. And since it's a very simple protocol, it's always worth checking to see if it is running. Many operating systems have an SNMP toolset built into it. Mac OS X, which is what I am using on my laptop, has that as well. SNMP Walk is also available on most Unix and Linux operating systems. In this particular case, we need to provide a community string, something you can think of as a username and password in one. The default for that is public, and most out-of-the-box installations will use that. The target that we are interested in taking a look at is this IP address, and you'll see that just by doing that, it's going to spit out a whole lot of information about the system that we just mapped. But let's run through this in a little bit more detail. We see some interesting data right away, such as we know exactly what operating system we're running, in this case Linux version 4.9. We're running this on a 64-bit processor using the Debian 4.9 kernel. The system administrator is me. But by knowing this, you now have something that you can use for phishing attacks, for example. The host name is Debian Eve, and we can start scrolling down a little bit further and see what other information we find. We can find information about the system hardware, physical addresses, in other words, MAC addresses, and we know what we can do with those now. A bunch of counters that we're not that interested in, but IP addresses that are in use in or by that computer. Different interfaces, local host, another IP address. All of those are IP addresses configured on that computer. And there's plenty more. The format looks a little bit strange, all these numbers. It's called a MIB, MIB, but it's really just nothing more than a code for a particular configuration, and you can look those up pretty easily. Let's see if we scroll down a little bit more, if there's anything else that's interesting that's popping out at us. IP addresses we talked about already. Some of them will also give us an overview of all the processes that are running on the computer. Now, I happen to know that this was SSH. Let's see if we can find it. Here we go. All the processes running on this computer. SSHD, login, SNMPD, and I'm sure we can find more. SSH daemons, system daemons. There's just a lot of information that you can get from a system by just running SNMP about it. And in the end, that's what we're doing, right? We're scanning. We're trying to build a picture of what this organization runs. We haven't actually tried gaining access yet, but we're just trying to learn more about what we can do. Oh, even better, look at these. These are all the software packages that are installed on the server, including the specific versions of the software that is there. So, as an attacker, this is a treasure trove of information. I don't have to guess anymore about what this system has installed. SNMP is telling it to me. So what do we do against this? Well, always change any default, so you should never have used public here. And even better is not using the version of SNMP that we're using here, but reverting back to SNMP version 3, or maybe not use SNMP at all.